So today we're looking at May, June 2022 K Pure Math 1 exam, Unit 1, Paper 2. So let's just jump into it right away. So first we'll be looking at Section A, Module 1, Question 1. Let P and Q be any two propositions, and we're asked to complete a truth table there. So let's get into it. So we have a Q column there. So not Q is really just the opposite of Q there, right? So not Q would be, okay, so not Q would be the opposite of Q. So true, so not Q, that's false. True, false, true. And these are the opposite for what we have in the Q column here. All right, now we deal with not Q and not P. So we're combining not Q and P. So that's the first and the third columns using the connective and. So true and false, that's what's true and false. True and false, that's false. True and true, that's true. The rest would be false, right? So the only time we have true is when both of them are true. And for the final column is P or not Q and P. So we're combining this third and the fourth column using the connective R. No, sorry, that's not the third and the fourth column. We are actually combining the first P or the fourth column. So we're combining the first and the fourth column here, right? Using the connective R. So once we have a true, the compound statement is true. So that's true, true, and then these two would be false, and the final would be false, right? Because false are false, that's false. False are false, false again. But once one of the statement is true, then the compound statement is true, using the connective R. Okay, so next we're asked to state whether the statements not Q and P, that's this statement, and P or not Q and P, that these two columns, we're asked to state whether these statements at the top of these columns here are logically equivalent. For them to be logically equivalent, they will have to be the same. The truth values have to be the same. And notice truth values are different. So not logically equivalent. And the reason for that, since the truth values are not the same, or we could say the truth values are different. If you notice the second to last column here, we have false, true, false, false, and the final column here, we have true, true, false, false. So notice these two truth values are not the same. So the two statements are not logically equivalent. Next is question 1, part B. Determine the values of A, B, and C such that, and we are given an equation there. Now, there are several ways we can go, and several routes we can take to solve this problem and find the values of A, B, and C. One of the ways we can approach this is to expand the brackets and equate the coefficients of the like terms. So let me just expand the brackets on the right hand side. So here I have 2x squared minus 7x plus 12 equal to, now let me just keep this A here. Let's expand these two brackets here. So x times x, that's x squared. X times minus 1, that's minus x. And then minus 2 times x, that's minus 2x. Minus 2 times minus 1, that's positive 2. The second bracket here, we expand by minus b there, right? So minus b times x, that's minus bx. Minus b times minus 3, that's positive 3b. and we have a plus c outside here. Alright, so we have a plus c. So now we end up with, let's simplify here. So again, we have 2x squared. Let's bring this forward here. Minus 7x plus 12. And if I expand here, I have ax squared minus ax. So distribute the a in each term to the bracket. Alright, so minus 2ax. And then a times 2, that's 2a. And of course, we have minus bx plus 3b. And don't forget, we have plus c there. Good? Now for let's equate coefficients. For equate coefficients, let's just try and factor the like terms here. So we have we have ax squared here. And then we have, for the x, if we factor the x outside here, would have minus x. Just factor minus x. Inside here would have right now we would have a minus 2a, and watch other x term is there. So we have this for x. This x term is also x term, and this would be plus 2a. Since we're factoring out minus x, this will be plus 2a. And then this would be plus b. And then remaining we have positive 3b and positive c. Just expand the bracket to ensure that we have the correct thing. So negative x times a, that's negative ax. Negative x times 2, that's negative 2ax. And negative x times b, that's negative bx. Alright? So now we can equate coefficients for the like term. So we're going to equate coefficients of the like terms. So let's go term by term now. So notice for the x squared terms, we have 2 on the left, and on the right, the x squared coefficient is a. So a is equal to 2. Now the coefficient for the x term, so notice for the x term on the left hand side we have negative 7. That's the coefficient for the x. And on the right hand we have a plus 2a. Well, actually it's negative a plus 2a plus b. Alright? And of course, if we times both sides by minus 1, we'll end up with 7 equal positive a plus 2a plus b. And we can continue to solve this. Notice if we group the a's, we end up with 3 a's. So 3 a's plus b. Now we found the value of a to be 2. So we can substitute 2 in this. So we get 7 equal 3 times a. Now we found a to be 2. So 3 times a, that's 3 times 2, which is 6, plus b. And therefore, if we subtract 6 from both sides, b is equal to 1. Alright, so a is equal to 2, b is equal to 1. Positive 2a should be here somewhere. Let me just put it. Alright, so this positive 2a would be among the constants. So what we have is actually 3b plus c plus 2a. Alright, so those are the constants on the right hand side. So 12. So note we have for b, the value of b is 1. The value of b is 1. So 3 times b, that's 3 times 1, that's 3. Plus c plus 2a. Now the value of a is 2. So 2 times a, that's 2 times 2, that's 4. So end up with 12 equal c, and 4 plus 3 is 7. So we subtract 7 from both sides. So the value of c is equal to 5. Let's put this better. So the value of c is equal to 5. Next, we have an inequality to solve. I mean, one way to solve these, we can square both sides, or we can look at it from a number line perspective here. So the modulus of 3x plus 2 is greater than or equal to 4. So let's do a small number line there. Alright, so the modulus would have to be, so this means that 3x plus 2 would have to be a larger number than 4. Or 3x plus 2 would have to be a smaller number than negative 4. So we can solve each of these. So if we subtract 2 from both sides, we end up with 3x is greater than 4 minus 2. 3x is greater than 2. Divide both sides by 3. Divide both sides by 3. So x is greater than 2/3. Alright? So the solution here, x is greater than 2/3. For the other one, if we subtract 2 again from both sides, we'll end up with 3x is less than minus 4 minus 2. So 3x is less than negative 6. So we divide both sides by 3. Divide both sides by 3. So x, so the solution here, x is less than minus 6 divided by 3, that's minus 2. So that's our solution for that. Okay, so next we have a logarithmic equation. Notice both of them are base 5. So we can just combine the logs, and it's addition, so we combine them by multiplying. Remember, log A plus log B is the same as log AB, right? So we can combine these as x plus 2 times x plus 6 equal to 1, which means that the base here to the power of, so which means that x plus 2 times x plus 6 is equal to here the base, the 5 here, to the power over here, so 5 to the power of 1, which is just 5. Expanding our brackets, x times x, that's x squared, x times 6, 6x, 2 times x, that's 2x, 2 times 6, that's 12, is equal to 5. So we can group the like terms, so we can group 6x plus 2x, that's 8x. And if we subtract 5 from both sides, group the 5 here, so 12 minus 5, what's 12 minus 5? That's 7, equal to 0. Alright, and then we can factorize. By a group, so x squared. We can rewrite 8x as 7x plus 1x, and then put back our constant 7. So we factor by groups. For the first group, we have x, bracket x plus 7. Factorize the other pair. We have 1, same bracket x plus 7. So our factors are x plus 7, and we are left with x plus 1. Alright? So we solve, so we equate both brackets to 0. So we equate x plus 7 to 0. We also equate x plus 1 to 0. So x equal minus 7 or x equal to minus 1. And those are our solutions. However, if we return, let's look at the equation again. If we look at the equation here, minus 7, if we substitute minus 7 in this, you're going to get a negative value in the bracket there. And remember, we cannot find the log of a negative value. So we'll just work with x equal negative 1. So if x is negative 1, the bracket will be positive. Negative 1 plus 2, that gives us positive 1. Negative 1 plus 6, that gives us positive 5. So which means that, I guess we'll throw out the negative 7 as a solution. Alright? And just leave x equal negative 1. Since negative 7 will make at least both brackets negative. And remember, we cannot log a negative value. Okay? Next problem. So question 2, that's functions. So First, we are asked to find the inverse of the function f of x. So we can let y be equal to whatever the function is, 3x plus 1 over x. And then we can interchange x and y. So if we interchange x and y, we end up with x equal to 3y plus 1 over y. And of course we can cross multiply, or we multiply both sides by y. So we end up with xy and 1 times 3y plus 1 equal to 3y plus 1. And of course we can group the y terms in y. So we have xy, group the 3y, we have minus 3y equal to positive 1 on the right hand side. We factor the y, factor out the y on the left, so we are left with x minus 3 is equal to 1, and then we can divide both sides by x minus 3. Divide both sides by x minus 3. So we're left with y equal 1 over x minus 3. And whatever you get for y there, that's your inverse function. So f inverse x is whatever you get for y, which is 1 over x minus 3. And the proof is complete. Next, hence or otherwise, write an expression for f inverse g of x. So we're going to plug g into the inverse function. Let's remind ourselves what g is. Now remember, g is e to the negative 2x minus 1. So in the function f, we're going to replace all the x variables with whatever we have for g, which is e to the minus 2x plus 1. So g is e to the minus 2x plus 1. We're going to put that now into the inverse function. 1 over, remember the inverse function is 1 over x minus 3. So we're going to replace x with what's in the bracket, e to the minus 2x plus 1, and then remember, so we put back the minus 3. So this becomes, if we group the constants, we end up with e to the minus 2x, and 1 take away 3, that's what, negative 2. Next, we have an exponential equation to solve. So one approach we could take is we could let y be equal to, we can let y be equal to what, 2 to the power of 2x, and then we substitute it into that, so we end up with 6 minus 7 over y. Since we're replacing y with 2 to the 2x, right? Minus 3 over, no, 4 to the 2x. Let's look at what 4 to the 2x is. 4 to the 2x, remember 4, so 4 to the 2x. Let's look at what 4 to the 2x really is. So 4 to the 2x is really, so we can rewrite the 4 as 2 square. So that's 2 square, 2 to the 2x. And of course, the law indices, we can swap these. So we can put the 2 to the 2x inside here. And the power 2 here is outside here. Alright, so these are equivalent. So the 4 to the 2x, we can rewrite it as 2 to the 2x all square. Alright, equal to 0. And the reason for that, I want to substitute y. So this becomes 6 minus 7 over y minus 3 over y square equal to 0. And we arrive there by rewriting 4 to the 2x as, we're rewriting the 4 as 2 square, which is 2 to the 2x all squared. Alright, let's continue. So we can get rid of the denominators by multiplying each term by y square. So y squared times each term. So y squared times 6, that's 6y squared. So I'm multiplying each term by y squared. So y squared times y squared times the 6, y squared times 7 over y, we end up with 7y, and y squared times the final term here on the left, we get minus 3 equal to 0. Alright, so we can now factorize. So we can factorize by a group. Let's use the AC method. Notice AC is 6 times minus 3, which is negative 18. If we think of numbers that factors of 18, we had what? 9 and 2. We had what? 6 and 3. What else multiply to give 18? 18 and 1. Alright, I think those are what multiply to give 18. Now, we need the two numbers to subtract to give negative 7. So negative 9 and 2 seems to be that pair. So we can rewrite the negative 7y as 2y minus 9y. Okay, let's do that. So 6y squared plus 2y minus 9y minus 3 equal to 0. And we factor by a group. So for the first, the common factor here is what? 2y. So we factor out 2y. We're left with what now? 3y plus 1. In the second pair, common factor there is what? Minus 3. So we're left with 3y plus 1 equal to 0. So we end up with the common factor 3y plus 1. And then what's left now? 2y minus 3 equal to 0. So we equate both factors to 0. So 3y plus 1 is equal to 0. 2y minus 3 is equal to 0. And we can now solve for y. So 3y equal minus 1. Divide both sides by 3. So y is negative a third. Or over here we add 3 to both sides. We get 2y is equal to 3. Divide both sides by 2. Y is equal to 1.5. So remember, the problem is not completed. Remember, we're asked to find the value of x. So remember, we had let y be equal to 2 to the power of 2x. So remember y, recall, y equal 2 to the power of 2x. Alright, so we can equate 2 to the power of 2x equal to y negative a third. And if we log both sides, and remember we can't log a negative number, so we log both sides, log of negative 1/3. So that's short because log of a negative number there doesn't exist. Alright, so we can also equate, so 2 to the power of 2x, we can equate that to the other y value, which is 3 over 2. Alright, 3 over 2. So we end up with, so we can log both sides. So if we log both sides, we end up with ln 2 to the power of 2x equal ln 1.5 or 3 over 2. Alright, law of logarithm. Now we can, this 2x here, we can bring this 2x at the power at the front here. So 2x log 2 is equal to log 3 over 2. And if we divide both sides by 2 log 2, that should give us a value for x. Alright, so divide both sides by 2 log 2. Alright, so log 2 cancel log 2 and 2 cancel 2. So we're left with x equal to log 3 over 2 divided by 2 log 2. And 2 log 2 is the same as log 4. So it's log 3 over 2 divided by log 4. Because this is really log 2. If I put the power here, it's log 2 squared. So the denominator could be written as 2 log 2 or log 4. Whichever one works. So now we're at part 2, part C. And we are given a cubic polynomial there. And we are told it's divisible by x minus 1. Which is pretty much saying that x minus 1 is a factor. And we are told it also has a remainder of minus 6 when divided by x plus 1. So we know x plus 1 is not a factor. So x minus 1 is a factor. Alright, so f of 1 equal to 0. Remember, f of 1 should give us the remainder. And if it's a factor, it means the remainder is 0. Alright? Also, f of, when divided by x plus 1, the remainder is negative 6. So it means that f of minus 1 should give us a remainder of 6. And f of 1 should give us a remainder of 0 since x minus 1 is a factor. So let's find f of 1. So f of 1, we're replacing the x value with 1. So 2 times x cubed becomes 2 times 1 cubed minus q times 1 square plus q times 1 minus 10 and that should be equal to 0. Let's see if we can simplify this. Now 1 to any power is 1, so 2 times 1, that's 1, minus q, just a moment, minus, just a moment here, this is an error here. So it should be p, right? Minus px squared. So negative p times 1 squared. Alright? So this would be 2 minus p plus q minus 10 equal to 0. And for the other one, let me just separate it. For the other one, now we substitute in negative 1, which will get it equal to 6. So 2 times negative 1 cube minus p times negative 1 square plus q times negative 1 minus 10 must be equal to negative 6. Alright, so in one case we substitute 1 for the x, in the other case we substitute negative 1 for the x. Alright, so here we end up with, if I group, then just group the constants on the right hand side. So I end up with negative p plus q equal to, it's 10, positive 10 minus 2. So I end up with 8 there. Alright, so group the constant on the right hand side, I'll get 10 minus 2, which is 8. And here, for this one, so this negative 1 to the power of 3, that's negative 1 times 2, that's negative 2. Minus p times 1, so that's minus p. Q times negative 1, that's negative q. Minus 10 equal minus 6. So if I group, so I put minus p minus q. If I group the constants on the right, I would end up with negative 6, positive 10, minus 6, that's 4, and 2. So I end up with 6 on the other side. Because the constants over here will be minus 6 plus 10, and then this will become positive 2. That's 12 minus 6, which is 6. So pause the video and try it for yourself. So we have two equations, a pair of simultaneous equations here, right? So I can put them together. So let me just put this one over here. So this is minus p minus q equal to 6. If I add them, I can add them since I recognize that the q would cancel with negative q. And minus p, that will become negative 2p. 8 and 6, that's 14. Divide both sides by minus 2. So minus 2 cancel itself here. So I left with p equal 14 divided by minus 2, that's minus 7. Now how do I get the value for q? I can substitute it in any equation. Let me substitute it into this equation here, replacing the p with negative 7. Alright, so negative p will be negative, and then the value of p is negative 7, right? Minus q equal to 6. So we end up with positive 7 minus q equal to 6. If I do some rearranging now, q over the right hand side, and then if I subtract 6 from both sides, I would 7 minus 6. So I'll end up with q equal to 1. So the solution, p is equal to negative 7 and q is equal to positive 1. Okay, so question 2 part D deals with the roots of a cubic polynomial. We are told that the roots of this equation here are alpha, beta, and gamma. Alright, so and we're asked now to find the roots, the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma. Good? So let's jump into it. Now we know the roots for this cubic polynomial here. We know the sum of the roots. So the sum of the roots, alpha, beta, and the gamma. The sum of the roots is what? The sum of the roots is what? Negative b is negative b over a. So the negative, so a, b, so the b value there is negative 1. So it's negative 1 over the a value there, which is 2. Alright, so the sum of roots, remember, is negative b over a. So a is the first coefficient there, which is 2. And b is the second coefficient there for the x squared, that's negative 1. Alright? And then the product of the roots, alpha, beta, gamma, is what? Is negative d over a. It is negative d over a. D would represent the constant, which is negative, well, the constant is negative 1. So negative d will be positive 1 over a, which is 2. Alright, and we are already told that the sum of the products here is 3 over 2. Alright, so we also have this information. Alright, the sum of the products there, that's 3 over 2. We're going to need that later on in the question. And we are asked now to show that, find the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma. Now, to get the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma, we need the sum. We need the sum. So 1 over alpha plus 1 over beta plus 1 over gamma. We need a value for the sum of all these 3 roots. And one way to do that, we can get a common denominator, alpha, beta, gamma. A common denominator, that would be the LCM there. And how do we get the numerator? So we times the 1 by beta, gamma. Better yet, let me just not skip any step here. All right. We need all of them to have one common denominator, alpha, beta, gamma. So this, let's change the color here. I need this to have a denominator of alpha, beta, gamma. So I need to multiply this by beta, gamma, right? But the whole idea of equivalent fraction, I also need to multiply the numerator by beta, gamma. So I have, alright? Likewise here, I need this to have the same denominator. So I have to multiply by alpha, gamma. It's beta, gamma, right? So I have to multiply this numerator also by alpha, gamma. Alright, so the first one here was beta, gamma plus alpha, gamma. And then for this final fraction, I need the denominator to be the same. So I need to multiply by alpha, beta. So I have to multiply the numerator by alpha, beta also. So alpha, beta. Notice they all have the same common denominator. Alpha, beta, gamma. So notice this value here, we're given this value as 3 over 2. So that's 3 over 2 divided by alpha times beta times gamma, which is a half. So that's 3 over 2. 3 over 2 divided by a half. 3 over 2 divided by a half is what now? 3 over 2 times 2. So that's 3. So all of this will work out to be positive 3. Good? We also need the product of these 3 roots. 1 over alpha. So let's erase this. Alright, we also need the product. So 1 over alpha times 1 over beta times 1 over gamma. We can just multiply this numerator. So that's 1 over alpha beta gamma. And no alpha beta gamma. Do we have a value for that? Alpha beta gamma is a half, right? So it's really 1 divided by a half. And what's 1 divided by a half? 1 divided by a half is positive 2, right? So the sum of the roots, so this is sum, right? And then this 3 represents the product of the 3 roots for the equation we want to find. We also now need the sum of the product, which would be 1 over alpha beta plus 1 over beta gamma plus 1 over alpha gamma. So we need this. But if you look above, the question tells us that all of that, what we just wrote, is equal to alpha plus beta plus gamma is equal to the sum over the product, right? Of alpha plus beta plus gamma over alpha beta gamma. Alright? So this is equal to alpha plus beta plus gamma over alpha beta gamma. Good? And alpha plus beta plus gamma, we already have that. Where was it? Alpha plus beta plus gamma, that's negative a half, divided by the product, which is a half. Alright? Not too far. So that's negative a half divided by a half, which is negative 1. So therefore the equation is, let's get the equation now. So the equation for part D, determine the equation whose roots are that. So the equation is x cubed minus, let me put the format, so it's x cubed minus the sum of the roots times x squared plus the sum of the product times x minus the constant. And the constant will be represented by the product of the roots, alright? Equal to 0. So in this case, the solution would, let me change the color just to make it more identifiable. So this would be x cubed minus the sum. What do we get for the sum of the roots now? The sum of the roots, we have positive 3. Oh no. So minus 3x squared. The sum of the product, it was the final thing we work out, which was negative 1. And the product was 2. So negative 1x minus the product, which was 2. Alright, so this would be our solution to the problem. Alright, so to get the equation, you'll need the sum of the roots, the sum of the product, and you'll need also the product. We found all of them. That's right, it's better. Alright, so that's our solution. X cubed minus 3x squared minus x minus 2 equal to 0. Okay, so we're on to section B, module 2. So this is trigonometry. Part A is a proof. Let's look at the proof. So now I will start from one side. Let me start from the side with the more terms. So it looks more complex. And I'll begin from the left hand side. LHS, abbreviating left hand side. So the left hand side, go back to blue. So the left hand side is tan theta sine theta all over 1 minus cos theta. And maybe one thing we could do is multiply by the conjugate of the denominator. So I'm going to multiply numerator and denominator by 1 plus cos theta, also by 1 plus cos theta. Alright? Let me do the numerator first. It's really a difference of 2 squares. So 1 minus cos theta times 1 plus cos theta. That's really 1 square. That's really 1 square, which is 1 minus cos square theta. Alright? In the numerator now, this will be, so tan theta sine theta times 1, so that's tan theta sine theta. And then tan theta sine theta times cos theta. So that's tan theta sine theta times cos theta. Now you recall that we have an identity. We call it the Pythagorean identity that says cos square plus sine square is equal to 1. So if I transpose here, if I do some transposing here, sine square is actually 1 minus cos square theta. Alright? So in the denominator there, you can replace 1 minus cos square theta with sine square theta. So denominator here is actually sine square theta. Alright? So and above, we have tan theta sine theta plus tan theta sine theta cos theta, right? And notice we can factor out sine theta. We can divide every term by sine theta. Alright? So let me just separate it. So we have tan theta sine theta over sine square. So we can just break up the fraction here since they share the common denominator. Let's break it up. Tan theta sine theta cos theta all over sine square theta. Now sine into this sine, so here cancel a sine down here. So what we have here is really tan theta over sine theta. And here, same thing happen. That was sine here. Cancel a sine down here. So we're left with tan theta cos theta over sine theta. Alright, so we end up with, what's tan theta now? Tan theta, recall that tan theta is sine theta over cos theta. Alright, and if you're dividing that by sine theta, just recall that tan is sine over cos, right? And here, recall that tan, what is tan? Tan is sine theta over cos theta, and then times it. This is cos over sine, right? So cos theta over sine theta. Alright? Now you realize that this is actually 1. Cos sine into itself, 1. Cos into itself, 1. So this is actually 1. And this here, so sine into itself 1, sine into itself 1. So what you have actually is 1 over cos theta plus 1. And if you just double check, this is what the right hand side was. Let's look at the proof again. So the right hand side was 1 plus 1 over cos theta. 1 plus 1 over cos theta. Remember, we're adding, so it's commutative. So the order is not important. So this is what the right-hand side is. Alright? So the left-hand side equal the right-hand side. So this proof, I would say, was quite easily done. So next, we have an equation to solve. So we have tan squared theta minus 2 tan theta. And then we subtract 3 from both sides. So we have minus 3 equal to 0. Good? And of course, this look like this can be factorized easily. You can so this is tan squared theta. And we can rewrite the minus 2 tan theta as minus 3 tan theta plus 1 tan theta. Alright, these two numbers, negative 3 and 1, they multiply to give AC, which is negative 3. And we add them, we'll get the middle term, which is negative 2 tan theta. Alright, so minus 3 equals 0. And of course, we can factor by groups. So for the first group, the common factor there is tan theta. So tan theta, in the bracket we'll have tan theta minus 3. And in the other pair there, we'll factor 1. So we're left with tan theta minus 3. So common factor there is tan theta minus 3. And then we have outside tan theta plus 1. And of course, we equate both factors to 0. So we equate tan theta minus 1. Tan theta minus 3 is equal to 0. Or tan theta is equal to, well, tan theta plus 1 is equal to 0. So solve it. So tan theta is equal to positive 3. Or tan theta is equal to negative 1. And we are told that the angle is between 0 and 2 pi. You know, 2 pi represents 360 degrees, so between 0 and 360 degrees. Alright, so if tan theta is equal to minus 1, you know, the primary angle is 45. Tan is presenting, so all science teachers are crazy. Alright, so tan is positive in the first quadrant for all and in the third quadrant. Alright, so the primary angle is 45. So theta would be, to get the other two angles, for negative 1, you will subtract the 135. You subtract, the 45 from the 180. So you'll get 135 degrees. And to get the other quadrant, you will subtract the 45 from the 360. You'll get 315 degrees. So if you're tan 135 degrees, you should get negative 1. And if you're tan 315 degrees, you should get negative 1. So tan is negative in these two quadrants, alright? Tan theta is equal to 3. So to get the primary angle, again, theta is tan inverse 3. What's the value of tan inverse 3? So tan inverse 3, if I'm using 1 decimal point, I think it's 71.6 degrees is the primary angle. And then tan is also positive in the third quadrant. So to get that angle, we'll add it to 180. So 180 plus 71.6, that gives us what now? 251.6 degrees. So tan of either of those angles would give us positive 3. Next, we're asked to show that 4 cos theta plus 3 sin theta is sin theta plus 0.927. We are given the angle here in the radians. Alright, so we can let 4 cos theta plus 3 sin theta is equal to r sine theta plus alpha. Alright? So our job is to show that the R value is 5 and the alpha value is 0.927 radians. Alright? So we can expand the right hand side. So 4 cos theta plus 3 sin theta is equal to, so we have R. Let's do the expansion now. Alright, so this is sin theta, addition formula, sin theta cos alpha plus sin alpha cos theta. So we use the addition formula for that. Alright, if we expand, we end up with 4 cos theta plus 3 sin theta is equal to R sin theta cos alpha plus R sin alpha cos theta. Good? So we can equate coefficients now. Let's equate coefficients. Alright? So on the right hand side, we're going to equate the coefficient for the cos theta. Notice for cos theta, the coefficient here is 4. On the left hand side, sorry, the coefficient there is 4. And on the right hand side, for cos theta, the coefficient there is R sin alpha. And let's do it for the sin theta now. On the left hand side, the coefficient for sin theta is positive 3. And for sin theta, on the right hand side, is the coefficient for the sin theta is R cos alpha. R cos alpha. And we can divide these equations by the other. So 4 divided by 3, that's 3. And then R sin alpha divide by R cos alpha. R cancel R there, right? So we're left with sin alpha over cos alpha. So we end up with tan alpha. Alright, so tan alpha is equal to 4/3. And we all should know the famous 3, 4, 5 triangle. If I draw a triangle like this, and alpha is, let's say tan alpha is, tan is what? Opposite over adjacent. So 4, 3. So this would have to be 5. Alright? Which means that sin alpha would have to be, well, do I need to do that though? Yes, to get the value of R. So sin alpha, sin is what? Opposite over hypotenuse. So the opposite is 4. The hypotenuse is 5. So sin alpha is 4 over 5. Alright, so we need to find R. So we can substitute it in this now to get the value of R. So if you look at here, look here, 4 equal to R times sin alpha. And we just find sin alpha to be 4 over 5. So R times sin alpha. So R times sin alpha, which is 4 over 5. Alright. And if I do some transposing here, if I multiply both sides by, to get the value of R, I can multiply both sides by 5 over 4. The reciprocal of this. So I multiply both sides by 5 over 4. That would get rid of that. And if I multiply this side by 5 over 4, you see it? 4 cancels 4 into itself. So we're left with R equal to 5. Alright? So up here, in the solution here, so the R value is a problem here. So it's, right, we'll let this be equal to R. So the R value here is 5. Just prove that. So to get the R value now, to get the alpha value now, with the alpha value, so we have tan alpha equal 4/3. So alpha would be tan inverse 4/3. And the answer in pi, if you put your degree in radian, you're calculating radian mode, you should get 0.927 radians. Alright, notice the question asks the angle in the radians, not degrees, so be careful to put your calculator in radian mode. So alpha is 0.927 radians. Alright. So we know for a fact that now cos theta So cos theta, 4 cos theta, sorry, plus 3 sin theta is equal to, as the question asks us to prove, 5 sin theta plus 0.927 radians. Plus 0.927 radians. Alright? So to answer part 2 now of the question now, for 4 cos theta plus 3 sin theta, alright, we know what that is, so we can replace it. So this can be replaced with this, since they are equal. So therefore, we can say 5 sin theta plus 0.927 radians, we are told it equated to 0. If we equate it to 0, and we divide both sides by 5, we end up with sin theta plus 0.927 radians is equal to 0. 0 divided by anything is, any non-zero number is 0, alright? So theta plus 0.927 radians is equal to 0 degrees. And if we take the angles between 0 and 360, where else is, alright, 180. I think sin 180 is also 0, but we're using radians, right? So 180 degrees, that's what? Pi radians. And also 2 pi radians. Alright? So sine of all of those angles would end up with 0. So which means that theta would be equal to, you subtract 0.927 from each of these possibilities, 0 minus 0.927 radians, or theta will be equal to pi minus 0.927 radians, and remember pi is 3.14. So you can take it as 3.14 minus 0.927 radians. And whatever you get, that's it. And the other one, other value for theta is 2 pi minus 0.927 radians. Let's just check it quickly and see what we get. So we'll end up with these values if we replace the pi with 3.14. So next, given that sine A is 1/3, I'll draw a triangle here. So A is 1/3, and sine is what? Opposite over hypotenuse. Sine is opposite over hypotenuse, right? So which means that the other angle here will be square root of, the adjacent will be square root of 3 square minus 1, right? So it will be the square root of 8. Good. 3 square, that's 9. Take away 1, that's 8. So root 8 would be the other side. Alright? So sine A is that. Now, of course, A is an obtuse angle. So this angle is what's an obtuse angle? An obtuse angle is an angle that is larger than 90. So the cos A, so if you look at it, let me just again do this. So all science teachers are crazy. So the angle, let's assume the angle is in this quadrant here. Since the sine is positive, and so that would be the angle there, that second quadrant there. So we need cos A. So in this quadrant here, the cos, only sine is positive. So the cos would be negative. So cos A is what? Cos is adjacent over hypotenuse. So cos is root 8 over the hypotenuse, which is positive 3. And of course, it would be a negative value, because if the angle A would be in this quadrant, and the cos is positive and is negative in this quadrant, alright? So cos A will be negative 8 over root 3.